Greetings, everyone. Today we're going to explore how to solve radical equations. You're going to need to apply your knowledge of roots and exponents to solve these equations. So we're solving. In the end, we want a value of x equals something. You'll definitely want to take some notes on these examples, and you may need a calculator. Solving equations involves getting that x alone so that you have x equals. You need to use inverse operations. For example, if it's adding, you want to subtract and vice versa. If the equation is multiplying, you want to try to divide. The opposite of square root is squaring. The opposite of cubing is cube rooting. And you may have to use some reciprocal fractions. Make sure you check your work by plugging it back in to see if it's a correct solution. Let's take a look at this example. My goal is to get this x by itself. So to start off, I'm going to move what's furthest away, and that is the 7. Instead of adding the 7, we do the opposite. Let's subtract. This leaves me with everything else still intact, but now I have 4 on the right side. Next, I have a 2 out front. The 2 is written next to the cubed root, therefore its intention is multiplication. So I'm going to do the opposite and divide. What you do to one side, you do to the other. This leaves me with the cubed root of x minus 3. And I have 2 on the right side. Now everything is under this cubed root. The opposite of cubed root is cubing. What you do to one side, you do to the other. Cubing a cubed root cancels, and I'm left with x minus 3, or whatever's under the radical, bring that down. And 2 cubed, if we use our chart, is 8. Last step to get x by itself is to add that 3 over, and we end up with x equals 11. Now we want to check our answer. So we want to take this equation, but instead of x, we want to plug in 11. So let's take a look. 11 minus 3 gives me 8. Cubed root of 8 is 2. According to PEMDAS, we want to take care of multiplication first. So 2 times 2 is 4. And 4 plus 7 gets me to the 11 that I needed. So that answer checks out. So on all of these, you'll know if you're right or wrong based on checking your answer. Let's take a look at this example. My goal is to get x by itself. First thing I notice is that both sides of the equation are under a cubed root. So I'm going to cube both sides, which takes care of those roots. I'm left with 2x plus 3 equals x minus 1, which is an equation you have been solving for years. You have 4 moves at this point, so at this point, if you're comfortable, take a moment to solve it the way you see it, and then check your answer with me in the end. We may take different steps at this point. I'm going to subtract x from both sides, and I'm going to subtract 3 from both sides. That leaves me with a 1x on the left and a negative 4 on the right. Divide both sides by that 1, which leaves me with x equals negative 4. Let me check my answer. If I plug in a negative 4 for each x, on the left side, 2 times negative 4 is negative 8. On the right side, negative 4 minus 1 is negative 5. On the left side, negative 8 plus 3 is negative 5. So in the end, I ended up with an equation where both sides are equal. Now, -5 isn't a perfect cube, but that's okay. It still is a value. It still has a decimal value. But I've proved that the left side does equal the right side. Therefore, my answer is correct. Let's take a look at this example. I need to get rid of that squared root to start off with. So in order to do that, I need to square both sides. I have to square the whole side. On the right side, that leaves me with 7x plus 15. But on the left side, take caution, you're squaring the whole thing. Therefore, that means I have x plus 1 twice. Watch out for those in your homework and on your assessments. When I have a binomial times a binomial, I need to use FOIL or the box method. I'm going to use FOIL. First, outer, inner, last. I'm going to combine like terms on the left. Now if I take a look, that x squared is not going to go away. So I'm going to move everything to the left side by subtracting it from the right side. That'll leave me with an x squared, negative 5x, and a negative 14. Now we need to recall the third quarter work that we did, where we have a trinomial equal to 0. In order to solve, I need to use AC method. Negative 14 and negative 5. Think a second of what factors multiply to get negative 14, but have a difference of negative 5. Negative 7 and 2. My next step would be to replace that middle term with my new middle terms, and then use grouping. Take an x out of the first set, take a 2 out of the second set. Perfect, I got the same thing twice. If I factor out an x minus 7, I have an x plus 2 remaining. Those are my two factors by using that grouping step. Now I have the option to set each factor equal to 0. Therefore, x equals 7. I add 7 to both sides. And x equals negative 2. I have two solutions that I need to check and see if they are true. So I'm going to first plug in a 7. Well, 7 plus 1 is 8. Remember, we're plugging it into the original equation. 7 times 7 is 49 plus 15. 49 plus 15 gives me 64. And yes, the square root of 64 is 8. So 7 checks out. Let's try negative 2. Negative 2 plus 1 is negative 1. Seven times negative 2 is negative 14 plus 15 gives me square root of 1. And so I'm saying that the square root of 1 is 1. Well, that doesn't look equal, so I just need to double check my work and make sure that that should have been a plus 2. It should have, which means I get x equals negative 2. Let me double check over here. Negative 2 plus 1 is negative 1. Therefore, x cannot equal negative 2. So it's very similar to that last unit where when you have two answers, one of them may not work, and that's okay. In preparation for the next class, you have a worksheet to work on for solving these radicals. Complete that worksheet and be prepared for class. See you next time.